Okay, this is Jeremiah Smith, and I am presenting my project for CSC 110. The final project is a coin toss simulation. Start off with the instructions. Coin tossing simulation to study probability by counting the relative frequency of a type event. Use the random module to simulate the experiment of tossing a fair coin n times, for n being 5, 10, 20, or 50. Simulate repeating the above experiment m times for each value n above using m, 1,000, 10,000, 100,000. For each combination of m and n, compute the probability that there are a number of heads and tails. This would be the relative frequency of number of heads and tails within an experiment. Repeat the above computations using an unfair coin with probability of head, probability being 0.52, 0.55, 0.6. For each of the 48 cases, write out a file with your results neatly organized and labeled, and using format identical to the file created by Mr. Wellman, the probability outcomes predicted text file. Write a second file computing the error, simulated probability and relative percent error times 100 for each case, and using the same formatting. Use the coin toss probs file that was also provided by Mr. Wellman. Discuss how you might use the above results to determine if a coin is fair. And now for the code. And so here we have the code. So we're going to start off by importing random, and then import CTOS. CTOS is the same as the coin toss probability file that Mr. Wellman provided. I just renamed it to CTOS. It's over here on the left. And we're actually only using the prob head function over here, and so I commented everything else out because we don't need that. And so we'll start off over here. Let's make this bigger. Okay, so we'll start off with the flip function over here. Flip returns a random heads or tails depending on the probability. The probability being 0.5, 0.52, 0.55, 0.6. Random.random gives you a random number between 0 and 1. So if you take the probability being whatever, you are modifying the chance that the random is going to fall below that. So heads if random is below 0.5, 0.52, etc., or else it's going to return tails, and that's pretty much all that flip does. Next we have toss, and here I've opened two out files. First being the simulated probs. It's going to be similar to the file output that Mr. Wellman provided, just with the large amount of flips you do. Then we have the predicted file that takes the simulated and predicted probabilities and compares the two and prints out the percentage of difference. And then down here we have a loop, for loop, that goes through and modifies the flips, which is going to be like n times 10 to the power 3. So n times 1,000, and then n equals 5, 5,000, n equals 10, 10,000, etc. And then n to the power of 4, so n times 1,000, and then n times 100,000. That's basically going to call, a flip 5,000 times on your first go. So then we have to set up a dictionary. The dictionary is basically the key of I with a value of 0, and then for I in range n plus 1, that's taking n, which is going to be 5, 10, 20, or 50 down there. So I'm setting up a dictionary to have a key of value of 0 through the number of heads, because like if it was just n, it'd be in range of 5, so you just get 0 through 4. So I added the n plus 1 to get 0 through 5, and that basically sets up all the dictionary keys that are just worth 0. Then we have, down here we have an empty accumulator. This is going to just keep track of probabilities that are returned so that we can add them up and compare them later. And moving down, oops. Next we have another loop. So in this one, we're basically taking I, which is going to be these numbers up here. And so depending on what sequence it's at, it's going to be like, 5 times 1,000 is going to be I. So the first one is going to be like 5,000. We're going to loop 5,000 times, and we're going to call flip. And we're going to populate a list with the results of whatever flip gives us. And this basically keeps track of the sets. So if you're doing sets of 5 1,000 times, this will populate with 5 heads or tails 5,000 times. So every time this loop loops, this will have varying sequences of heads or tails. And this next dictionary down here are going to increment every time this loop loops. We're going to go into that dictionary, and the key value being the count of H, we're going to increment that by 1. So if this list came back with 3 heads and 3 tails, then we're going to modify the dictionary that has 3 heads. So it'll be the dictionary of 3, and then we're going to add that by 1. So we're doing that so that we have a total count of heads of how many times 3 heads has come up from a flip, and then that way we can use that to write down the probabilities. So this is just down here. This is just a print formatting. This one is just on 2 lines. They are repeating because one goes to the first out file and one goes to the second out file. The 2 files have pretty much the same heading. Then we have tosses, in being 5, 10, 20, or 50. The first loop would read number of tosses, 5 times I, which is these numbers up here, and so that's the header. The next header will be the probability of heads. P is the 0.5, 0.52, 0.55, 0.6. So that's going to list the probability. And then we're going to take the probability of tail, which is the 1 minus P. So if you have probability of 0.55, the probability of tail is going to be 1 minus 0.55, which is going to be 0.45. Then we output that to the first output file, and then do the same, for the second output file. And then down here we have print another couple lines, and then Then we change things up a bit. So in these print statements down here, so the first one keeps track of the heads, tails, and the probability of event. This is all the simulated file, which is the out file. There we go. Sorry, I had to adjust my screen a little bit there. I couldn't see anything. So anyway, where I left off at, we'll go over this one again. The first one keeps track of the heads and tails, and then the probability of event. This is all the from the simulated file, which is out file 1. And then for the out file 2, we have the heads and the tails, and then the difference of probability. And these are just headers for the files. Okay, so next we start manipulating stuff inside the dictionary. And this is how we're going to get our probability. So for K in dictionary, the probability of event is equal to the dictionary key value. So for every key value we have in the dictionary, we're going to say the probability of event is the dictionary K divided by I. And then we add the probability of event to the accumulator. So this is going to keep track of the sum of the probabilities within each loop. Then we have predicted. That's going to call the function from the external file CTOS. We're going to send it N, K, and P. N being number of tosses, K being the key from the dictionary, the number of heads, and then P, the probability, the 0.5, 0.52, etc., probability of heads. And then it does whatever it does to get the probability. So I have it named predicted, so whatever that value ends up being, that's what it assigns. Then we have error. This is going to be the discrepancy between my probability and Mr. Wellman's probability from his file. His being the control, so I've done ABS, which is absolute value. That's basically going to ignore the signs. If it's a positive or negative, it doesn't matter. It's just going to find the difference between the two. So we have ABS predicted minus probability of event for his and mine. Then we have a few more print statements. So these print statements take the results of this stuff and then prints out the either the first output file or the second output file. The first output file will take in K, which is the key value. Then it's going to take the number of tails, which is the number of flips minus the number of flips minus K, which is the number of heads. Then we have the probability of event, which will be 0.1 or whatever. So that's going to give us the percentage of difference between the two simulated and predicted probabilities. Then we send it to the second output file because that's our differences file, basically. At the end of this, we must close the file or else nothing gets written to the file.